22 is on the derivatives of inverse trig functions. So inverse trig functions are the things like y equals sine to the negative 1 of x, right? So inverse sine or arc sine you might see. So if you recall from pre-calc, when we draw just the sine function in general, the sine function we know starts at 0, 0, it goes up, it comes down, it goes back up, and so on. So that's the sine function. But this function is not one-to-one. Okay, we're doing 22, not 21. So it is not one-to-one. If you remember, one-to-one means it passes the horizontal line test. This does not pass the horizontal line test. So instead, we restrict the domain. So we instead think of it from here to here, and then it is one-to-one. Okay, and then we have the inverse of it. You could graph the inverse of it by switching all your x's and y's. We're not going to graph the inverse. We'll just kind of talk about sine. So that's the sine function. So if you think about the unit circle, every single sine value, so from -1 to 1, can be found on that right side of the circle. So if I wanted a y value of -1/2 on the unit circle, it would be over here, right? If I wanted root 3 over 2, it would be up here. We can get every single y value possible just on one side of the curve. Okay, so that's why we restrict it to only -π/2 to π/2. So it makes it pass the horizontal line test, so we can find a unique inverse. Okay, so we say that inverse sine of x equals y if and only if the sine of y is equal to x. So y is an angle between -π/2 and π/2. Get it? So the inverse cosine function is very similar. Do you guys remember where we restrict cosine? So, yeah, it's 0 to pi, because it starts here and then it goes down and then back up. And then it goes down and then back up, and so on. So if we restrict it only from 0 to pi, then it's going to be 1-to-1. So if you think about the unit circle, every x value of our unit circle can be found on either the top half of the curve or the bottom half of the curve. So we choose the top half. And this is consistent with what the calculator answers give you. The calculator only gives you one answer. Like if you were solving an equation and you were like, okay, I know that I want to find when sine of an angle equals root 3 over 2. There's actually two places on your unit circle where the sine is equal to root 3 over 2, but your calculator only gives you one answer, right? And then you had to kind of interpret to find the other ones. Does that make sense? So it gives us one unique answer. So it's restricted to the domain 0 to pi. Okay, so there's a really cool proof on why the derivatives are the way that they are. But students never liked it, so I'm not going to do the proof of why the derivatives are these things, but the derivatives are at the bottom here. We'll go ahead and do number 1 here. It says, why does inverse sine of π/4 equal π/4, but inverse sine of 7π/4 does not equal 7π/4? So a lot of people think that they just cancel each other out, but they don't really. Do you guys remember this from pre-calc? We did this in pre-calc. So if I start on the inside, so if I'm like, okay, inverse sine of π/4, and I start from the inside, and I'm like, well, what's sine of π/4? Sine of π/4 is root 2 over 2. So when I talk about inverse sine, I'm saying inverse sine is restricted to the right side of the circle. And we're saying, where is the y value equal to root 2 over 2? It's right here. So if I'm talking about between -π/2 and π/2, that value would be π/4. Right? But if I do inverse sine of 7π/4, sine of 7π/4, well, where's 7π/4? It's down here, right? So it's going to be negative root 2 over 2. So it's inverse sine of negative root 2 over 2, which is still in that same location, but when I talk about the angle, I say it's between -π/2 and π/2. And you can try this on your calculator. Your calculator does not give you 7π/4 out. It gives you a negative number. And that negative number is -π/4. So it's the same answer, it's just in another location, right? So negative, or it's in the same location, it's just a different numerical answer. Do you guys understand? It's like what we call coterminal angles in pre-calc. They're exactly the same location, but they have different names. Yes?
I just want to make sure you knew that was π/4, like the inverse.
How I knew what was?
Like inverse of like sine of -1.
Like here?
Yeah.
Because what you're saying is sine of some angle equals root 2 over 2. You're going backwards. So you're saying, what angle do I plug in to get root 2 over 2? And there's 2. It'd be here and it'd be here. But the inverse sine function restricts it only to one side.
Okay.
Okay. All right, and then cosine. So I have inverse cosine of sine of 7 pi over 4. So we just said sine of 7 pi over 4 is in the location where we get a sine value of negative root 2 over 2. So if I talk about the cosine value then, cosine is restricted to the top of the unit circle. Our values are always between 0 and pi. So we're saying cosine of what angle gives us negative root 2 over 2 out? What angle would that be? 3 pi over 4, exactly. So that's kind of how inverses work. You say cosine of what gives me this number. Okay, so here's our derivatives. Okay, I say I would recommend memorizing inverse sine and inverse tangent. These are the ones that I have seen on the AP exams. So every practice exam will have these ones. Okay, so inverse sine and inverse tangent. Those are probably the most important. Okay, that's all I make you memorize in my class. Now, could the AP test put the other ones? Sure, they're on the list of topics that could be on the AP exam. And I feel like every year the AP Calc exam gets just a little bit harder because that's what they do. So, maybe you should memorize the other ones, but there is a pattern. So if you look at sine and cosine, what do you guys notice about those? They're pretty much the same except for what? There's a negative on the co, right? On the cosine. How about tangent? Tangent and cotangent. There's a negative on the co one, right? How about secant and cosecant? There's a negative on the co, right? So if you can remember at least sine, tangent, and secant, then you would be good. You would have every single one of them. All right, so let's try some problems. So it says find the derivative for numbers 1 through 3. Okay, so here's the two that I told you to memorize. So I said that if you have y equals inverse tangent of x, its derivative is 1 over 1 plus x squared. That's the first one. And then if you have y equals inverse sine of x, its derivative is 1 over the square root of 1 minus x squared. So this one says arctan. Arctan is exactly the same as inverse tangent, right? That's the same as tangent to the negative 1, like that. Same thing. Why do we write that? Because as math teachers, we don't like raising things as exponents a lot of times. So it's an easy way of writing it. So back when we typed everything on a typewriter, and you guys don't even remember the days of typewriters. I had a typewriter when I was growing up. We couldn't like raise things to power, so we wrote things as arctan. All right, so if I find the derivative. Okay, we want to think about what form this is in. We're definitely using the chain rule. What's our u? What's the inside? X squared, right? So this is in the form y equals tangent of u. Okay, so when we take the derivative, it's going to be secant squared of the u, so of the x squared, times the derivative of u, so times 2x. So this was our u, this was our derivative of u. So we're just using the chain rule. And we can leave it like that. All right, so the next one, this is in the form oh, why did I do that? Oh my gosh. I'm like totally spacing up. You're right. So I was thinking it was just tangent. Inverse tangent, what this whole lesson is on, right? Inverse tangent. So it's going to be 1 over 1 plus u squared, so x squared squared, times the chain, so times 2x. So it's going to be 1 over 1 plus x to the fourth, and then times the 2x, so we're going to put the 2x on the numerator. So I wrote in the form tangent of u. In the form inverse tangent of u, that's what I did wrong. So we have our u, and we have our du, our derivative of u. I know, were you like, this is the same as what it was? I threw myself off when I wrote y equals tangent of u. Yeah. As long as you don't have an x, you always have that chain, right? And x even has a chain, it's just 1. So this is in the form inverse sine of u, right? So y prime is going to be 1 over the square root of 1 minus u squared. So our u is 4x, so 4x squared, times du, so times 4. Okay, So we just simplify. We get 4 over the square root of 1 minus 16x squared. All right, so number, oh, did I skip 3? Was there a 3? Yeah, okay. I always forget to scroll down. All right, so think about this. This is in the form inverse tangent of u, right? So when we take the derivative, it's going to be 1 over 1 plus our u value squared, so square root of x squared, times du. Do you guys now know the derivative of square root of x right away? 1 over 2 root x, good. Or you could write 1/2 x to the negative 1/2 and change it. So this is 1 over, we have 1 plus x times 1 over 2 root x. So we're just going to write it as 1 over 2 root x and then parentheses 1 plus x. You could multiply the 2 root x in if you wanted to, but we'll just leave it like that. All right. And then the next one is about finding the absolute max. Okay, so when we're finding a maximum or minimum, we haven't done a lot of like graphing and finding maximums and minimums. Basically in calculus, we're going to learn how to graph any function that you've ever seen. So we'll know how to find maximums and minimums and x-intercepts, y-intercepts, and so on. So if I have a maximum of a function, usually it happens when the derivative is equal to 0, right? Occasionally it will happen at a corner or cusp where the derivative is undefined, but usually when the derivative is equal to 0. So whenever you see something that says find the absolute max or find the absolute min, you want to set the derivative equal to 0 or undefined, okay, to find what's called critical values. So we're going to find f prime. So the derivative of inverse sine of x is going to be 1 over, do you guys have it down yet? The square root of 1 minus x squared, exactly. And then we're going to have minus 2. And we want to set this equal to 0. I'm going to add the 2 over. The chain is just 1 in this case because it was inverse sine of x, so the derivative of x is 1, so we don't need it. And then you could do a couple different things. You could square right now, or you can multiply that square root over. You could divide by 2, or you can square now. It doesn't matter. In algebra 2, we typically isolated the radical, if you remember. So we square and square. So we get 1 minus x squared is equal to 1/4. That's the first thing. Then I'm going to subtract the 1 over, so I get negative 3/4 equals negative x squared. So we'll divide by negative 1, make that plus plus. Square root, plus or minus. So I get x equals plus or minus the square root of 3 over 2, right? Square root of 4 is 2. Those are what we call critical values. So something is happening there. The derivative is equal to 0 there. Okay, but we don't know if those are maximums or if they're minimums. One could be a max, one could be a min. They both could be maximum. There could be weird things going on. All right, so let's figure it out. So what we typically do is we put our number line, and I have endpoints on my number line because I want to remember that I'm only on the interval negative 1 to 1. So I'm going to put negative 1 and 1 there. And I'm going to put my critical values. You guys remember dealing with critical values even in like algebra 2 and pre-calc? We did critical value type things. We tested in the intervals. That's what we're doing. So we're going to test numbers that are in between these things. We're going to test a number in the derivative. And we're going to see if it's positive or negative. Okay, so if you do square root of 3 over 2, it's like 0.866. You guys have probably done that before on your calculator, right? Or seen that. So let's do like negative 0.9. And we're going to plug into the derivative. So plug in right here and decide if you get positive or negative. All right, so when you plug in, 1 divided by the square root of 1 minus 0.9 squared. Okay, I get a positive when I plug in both positive 0.9 and negative 0.9. So I'm going to put it on both sides. And then if I try 0, I get 1 over 1, which is 1, minus 2, which is negative. Okay? And we'll be doing a lot of this, so if you're confused on this, don't worry. Like, we'll do this many, many times. So what this means, if f prime is positive, what does that mean on our graph? If the slope is positive, it means what? The graph is going upwards, right? So the graph goes up, and then the graph goes down, and then the graph goes up. There are two possibilities for a maximum. What are the two possibilities? Not infinity, though. One, right? Because there's an endpoint. Or this one, right? Does that make sense? So since we're on that closed interval, we have to test that one. So now we go back and we compare their heights. So we're like, well, what's f of 1 and what's f of negative root 3 over 2? So f of 1, if you go back all the way to the beginning, you get inverse sine of 1, and we know inverse sine of 1. Sine of what value gives you 1? It's pi over 2. Minus 2. So we'll just go ahead and do it on our calculator. So we're going to do inverse sine of 1 minus 2. Make sure you're in radian mode. You should get negative 0.429. And then inverse sine of negative root 3 over 2 minus 2, or minus 2 times negative root 3 over 2, actually. What did I do? It was the negative, yeah, because those are our two possibilities. So we get 0.685. So which one is taller than the other one? Right, the negative root 3 over 2. So that's where our absolute max is. Absolute max just means what is the highest value on the entire graph. So basically we have some kind of graph where it goes up, it comes back down, but then it doesn't go up as high as it had been before. Okay. So we say absolute max, absolute max of 0.685 at x equals negative root 3 over 2. So we're saying it goes up to this highest point at this certain x value. Does that make sense? Yeah.
How did we find f1 again?
I just plugged back into the original. Yeah. And I just did it on my calculator. Okay, do we understand this section? It's really not bad. There's two derivatives you need to know. So what was the derivative of inverse tangent? Oh, no peeking, Evan. 1 over 1 plus x squared, right? What about inverse sine? Okay, did you guys just peek? You probably peeked. All right, so know those, though. I'm going to make you memorize all of them. Remember I told you I'm going to give you a drill on these. Like a multiplication drill that you used to do in elementary.